Hello everyone. My name is Rohan Dubal and I'm a software development engineer with the AWS mobile team. Welcome to the session Developing Well-Architected iOS Applications with AWS. Here I'll cover let me suggest a related workshop. So tomorrow we are also doing a workshop where we are going to cover how you can use all the AWS tools to build a cloud-connected iOS game. So we are going to take the open source Flappy Bird game. So there's an open source version of Flappy Bird, which you can just use to play Flappy Bird. What we are going to do is take that game and add cloud-connected features like leaderboard, user authentication, and user analytics. It's going to be almost a 2.5-hour hands-on session. So if that's something which interests you, you can sign up for it. So that's tomorrow, and the session title is MOB308. So just a little bit about myself. So I'm currently working on the mobile SDKs where we focus on the Android, iOS, Unity, and Xamarin side of things. We try to develop and maintain the interface which is required to access AWS resources from the mobile phones. And today's agenda is essentially starting with what are app development requirements. How do you start with knowing what are the requirements? We'll be covering what are the end user requirements, what are the business requirements, and then what are the absolute essentials for a developer. Then we'll move on to the development lifecycle where we are going to talk about how do you determine which services to use? How do you determine where to write the code? How do you focus the logic on client? How do you focus the logic on service? And then we are going to start moving to different tools and services, which will be a detailed demo of which services are there and how they are used in the apps. Finally, we'll conclude with some takeaways and useful tips which you can keep in mind while developing the apps with AWS or otherwise. So now starting with requirements, let's take a step back and see why do you want to write an app? If you think about it, the simplest answer is I have an idea, I want to write an app for it, which is great. Or if you, in a more professional setting, it's I'm working for this business and this business is already an established business and now I want to have a mobile interface for it. That's a good area or good idea where to start writing an app for it because you have new customers who you want to address. Or you could even be something like, I just want people to see cute cat videos and I want to write an app for it. So the use cases could be anything, but that's how it usually begins, I want to write an app for something. Every app which is written will be written with keeping in mind a set of users. You have, if you're writing an e-commerce app, you have a potential set of people who are looking to buy products. So what do these end users expect when they are downloading your app and they are seeing an app or any mobile app? The first thing is data security. Data security is the most essential thing in today's world. Users are very savvy about what happens with their data, how it is stored, how it is used, who it is shared with, and is it accessed by someone who should not be accessing the data. Customers have a very high requirement about knowing how the data is handled and that it's well protected. Then it comes to the actual app usefulness. If you're using an app and it doesn't work smoothly, it doesn't scroll nicely, users are not going to like it. If you see any modern application or pick any app in your phone, open it and you'll be welcomed with a scrolling interface. You will be scrolling it so many times, every interface will be having some sort of scrolling with it. So it's very important that you write your apps which keep that in mind, address that by prefetching data when required, storing data in advance. Then it's personalization. So many people feel that they are more likely to use the app if the content in the app is personalized to them. What this means is, say you are an e-commerce app, right? You visit some products and then you see recommended for you. Sometimes you are not considering that product which is recommended and you realize oh yeah, actually this suits my needs better. Like that is kind of like makes you more interesting in using the app. Like, oh yeah, this app is kind of always is helpful in suggesting me what I want, so I'll probably use this app. And the next thing is fast data access. Say you have a video streaming app where you want everybody to see cute cat videos. So will it be acceptable that there is a lag and suddenly the video stops? Probably not. So you have to make sure that your data is available at a quick speed. You have to plan for network bandwidth. Like if your data is not available immediately, you like switch to a lower stream where you can have a lower bit rate, and then the data is available at a faster rate, and the user interruption is uninterrupted. User experience is uninterrupted. And the exact opposite of fast data access is offline, which is like no data access. You do not have access to network data. A lot of businesses and a lot of use cases require offline data access. Say you are a music streaming app. The whole premise of using that app would be availability of offline data. If I cannot use my app while I'm on my airplane, or if I cannot listen to my music while I'm traveling on my subway, that would be a very bad experience, and I'll probably drop out of using the app. All of this, you can think of it as what are the reasons that help me keep an app, and what are the reasons that don't help me keep an app. Like, what are the reasons why you would delete an app? If you think about it that way, you have the priorities which you want to focus on. Just take some few minutes after this session and think about it, like why do you have an app, and why and the apps which you deleted, why did you delete them? And you'll kind of get like, oh, I should be focusing on these things because I deleted an app because of it. Moving on to the other side of the coin, which is the business requirements. If you are a big organization developing an app for your business, or if you are an independent developer who is writing an app just to like see if like their idea is working or not, you always have to think that how to grow this app, or how will the people use this app, like, and these kind of contain the business requirements. So let's see what are the top business requirements while making an app. So even here, the first thing which you have to keep in mind is data security. You do not want to be in front of a newspaper saying like data breached for this company, or data shared where it was not supposed to be. It's a bad PR. People stop trusting your app and they delete the app. Acquiring customer trust is very difficult, and it should be well thought of, and security should always be given the priority. Next is availability. So again, back to my example of being an e-commerce app. If you are writing an e-commerce app, then your whole business relies on people buying stuff from the app. And now if your data is not available, it takes a hit on your business. The revenues drop, and it can be very detrimental. And this is apart from the fact that the customers won't be able to buy what they want to buy, and they will probably say like, oh, this app is very unreliable, I'm probably not going to use this, I'll just go buy from someplace else. So data availability and data security are the two most essential things which are required by the business. They have become a business requirement rather than something else. Next is user behavior. It is very critical to know how the users are using your app. The users could be, maybe the users launch the app, great, but they're not able to use the app and then they drop off. And you don't know like why did they drop off, or how do you determine what feature set to deliver next. User behavior, understanding user behavior helps you plan for your next stuff, helps you plan every update. So it's important to record data to understand how the users are how using their app and where they are facing issues and what parts they are liking it. The next is user adoption. Now, once you understand the user behavior, have a great app, you want the app to grow. You want to understand what kind of users you can target to increase the app usage. If you are an e-commerce app, you want people to buy more products. If you are a gaming app, you want the people to keep coming back and reuse the game. This could even be sending notifications like a new level is available, or you are awarded like 100 bonus points. Like if you're using Pokemon Go, you keep seeing things like, well, this is available, if this is available. Like that kind of things is what contains in user adoption. Now, having seen these both requirements, let's focus on app development essentials, which is what we as app developers focus on or should keep thinking about. The first thing here is, again, authorization. I'll keep repeating this because it is that important. You need to know who is accessing your app or who is accessing data within your app. That helps you understand and plan how people, like who is using which data and if they are allowed to use that data. You have to be very particular about what data is sent to the mobile device, because once it's there, like they are seeing it. So it's very critical to have good authorization in your mobile app. The next is developing for connectivity. Now, this is one of the part where a lot of testing is required but is not done. And connectivity just doesn't include like connection between like fast network and connection in a slow network or anything like that. It's planning for every step of connectivity. When we do the development in our offices, we have like amazing network connection. It's fast, the data is available. It's like we write the code, we say like, yeah, everything's working, I tested it, it's great, it's ready to roll out. But in reality, that's not always the case. There are some regions who do not have that great 4G LTE connectivity. There are some regions which have either like 2G connectivity or 3G connectivity, and they don't work great. You have to build your apps to account for such kind of network connectivity. There is network link conditioners which you can use to simulate such environments, which help you understand like, oh, this network is so slow, why is my app misbehaving? Am I retrying too much if my request failed? Like, am I consuming battery? And that's very important to know. And the last thing is offline. Always test the app like how it behaves when you are offline. If I am logged into the app, I'm in a different area of the app. And now if there's no network connectivity, how does the app behave? It's very important to plan for these small things. Moving on to the resources, it's important to know that we are writing an application for a mobile device. Now, a mobile is a very limited resource unit. You have limited battery, you have limited network bandwidth, and you have limited storage. With all these three limitations, you have to be very frugal with how you use these resources, because the moment you start using any of these resources more, it will have a bad effect on your user or you, because say you are using excessive network data, that will cause a battery drainage as well as potentially a lot of money to the customer or the end user who is using the app, because they might not know it. So you have to think about it and like either make them aware that we are going to use network data and allow them to control it, or just use it very sparingly. You can have like app UI limitations to restrict usage of network data. Similarly, battery, you should not be using too many resources and like use everything sparingly. Moving on to the next part, telemetry. So if you see the last three things like authentication, connectivity, and resource consumption, these are part of ongoing app development. So once you have an app ready and it's ready to be rolled out into the App Store or Play Store or anywhere, how do you know if the app is behaving as it should be? How do you know if it is doing what it was supposed to be? Like we always say like, well, it worked on my machine or it worked on my device, but you can't really do that, because once your app grows, it will be into the hands of so many different users in so many different conditions and so many different usage patterns. It's never possible to test against every single thing of this. So it's important that we collect data and send it for analysis so that we understand like, is the app working correctly or no? So it could include things like how much time does it take for a view to load up? That is a telemetry. If the app is crashing, you record which device was it or which OS version was it. This will help you find help release a patch fix which is targeted to that OS version or to that device. So say iPhone has like increased the display sizes recently, right? So maybe it works great because it's tested on these new devices, but what about the small devices? Is it working as expected? Have we tested all the cases? So it kind of helps you understand how the apps are working across all the spectrum. The next is app update. Now, app update is a thing which keeps on happening repeatedly. Every time you have a new feature or you have a bug fix, you have to release an app update. Like now, we don't want to release too many updates, because every time you release an update, the customers have to download the app again and again. So you want to batch them and release it. But one thing which I want to specifically call out, which I haven't seen many apps handle that, is the force update part of it. Either some apps are very aggressive in doing a force update of their apps or are very relaxed about it. There always has to be a balance about how to do that. You cannot have a force update every month. That's too much. Like, people will drop off. And you cannot have like there's no force update. You have to plan for force update in a way that if there is a security loophole discovered, or if there is any issue discovered which requires a release, only then you use that switch and ask people to force update their app. So these are the things which, as developers, which we need to keep in mind when we are writing apps which connect to the cloud. So now that we have covered the business requirements, the user requirements, the app development essential, let's actually get started in like writing an app. So I'll be taking an example today of a photo backup app. We have seen so many different solutions of photo backup apps. I'm pretty sure everyone uses some sort of photo backing up mechanism. I can understand that there will be someone who would go the traditional way of copying it in a hard drive, but cloud backup is an increasing trend. So if you see any photo backing app, what does it do? It allows you to create an account. It allows you to log in. It allows you to see what you have backed up. And it allows you to set up a sync mechanism or manually select files and upload them. Some advanced apps also allow you sharing between users, but I'll keep it focused to individual private backups for this session. So first thing is focus on front end. As iOS developers and mobile developers, our focus should be, what does my user need? Like, we should not start with like, well, the backend has this API and I want to design my app around it. No, that's probably not a good idea. In this recent world, it does not require that you always abide by how backend is set up and then plan your API around it, plan your app around it. You can always have data layers in between the backend and your front end to suit what is required in your application. And with the services and technologies available in this time, it's easily possible to do so. It's also like good to keep in mind that backend is not going to go away, but interacting with it, managing it is getting simpler. So I'll cover that in the slide, because every time you are trying to develop something, it's like, what about backend? Like, who will manage this API? Who will do, like, I don't know how it works. Like, I don't want to manage servers. I don't want to manage this data center. So let's see how we can simplify this. So coming to the backend management part, the first thing about managing backend which I can say to you is, don't do it. Now, there are reasons why I would, and I'll tell you why it's not a good idea to do it in this world, because everything is moving towards serverless for security and scale. Now, how many of you know what serverless is? Oh, good people of number. So for those who don't know, like a short summary of that is, your apps and your applications or the backend still runs on some servers, but they are not managed by you. They are managed by, say, AWS, where we have Lambda, API Gateway, or AppSync, which manages your data API access on the backend. These servers scale automatically based on increased demand. Like, if suddenly your app becomes very popular, like everybody wants to see the cute cat videos which you have in your app, and like there are 1 million customers flocking your app, you do not have to worry about like how are you going to access that load. AWS will scale the backend to meet its requirement, and then you worry about like, but what about the money? I don't want to have so much money. So payment is on use basis. So if your app is not used by anyone, then you won't be charged for it. But if it's required, the scale will be increased, and then you will be charged only for the amount used. But then you think about it like, okay, well, that's great, but how do I know which service to use? Like, I just told names of 3 services right now, like, and the AWS has a lot more services. What is good for my app, and like, how do I know which is good for app? So we got a lot of these things, and then we had a solution for this. And the solution which we came up recently was the Amplify toolchain. We launched this open source CLI tool which helps you configure backend resources with AWS. Now, Sure, it will. You'll think that well, it's going to make some things easier, but I still don't know how to use services. So what we have focused on in Amplify is in a way that you ask for, I want to configure user authentication. Like, great. So just type this, Amplify auth add. So you type this with Amplify, and what it is going to do is it is going to pick the best service for user authentication on mobile devices, and then configure it with AWS Cloud so that it's available for you to use immediately. Then in our photos backup example, you want analytics as well. So just write this like Amplify analytics add. Now what this is going to do is going to wire up the user authentication and user analytics in the backend for you and make it available for you as a developer to use. Then like, well, what about photo storage? I want to store the photos somewhere. So like this is the command, like Amplify storage add. So if you see a pattern here, what is happening here is we have identified the categories which are most likely to be used in implementing a mobile app, which is auth, analytics, storage, API, bots, and things like that. So I would recommend check out the Amplify CLI tool to get started with backend development, and we allow you to grow as well. Like it looks very simple at this, but it also has a lot of configuration option. For example, the API auth add, you can either go with the default secure configuration, or you can choose everything like multi-factor authentication, user device features. Then what message do you want to be sent when someone signs up, like your message, your authentication code is this, or say from hello from this app, this is your authentication code. You can even customize messages like this right from the CLI. But we always make sure that the first step is very easy to use and has the most commonly used and best practices. And once you are done configuring all of this, you can do how much your prototype you want with your configuration. And once you're ready, you write this command, which is Amplify push. And what it is going to do is going to deploy all the resources which you either configured or updated into the cloud. And that's it. You don't have to do anything else. Now, configuring this was super easy. So let's just go through what Amplify CLI did when I ran these commands. So this is again an architecture for our photo backup app. So this is what I have currently. So if you see Cognito, this is what is used for user authentication. This is currently by default used when users see your app and log in or sign in, sign up, sign out. All the operations are handled by Cognito. It also acts as access control for what resources you are accessing in the backend. So it acts as a gateway for accessing AppSync, S3, Pinpoint, etc. And then we have Amazon S3. Like I'm pretty sure most of you are aware about S3. So it's a simple and secure cloud storage solution, and that will be used to store our photos which we'll be uploading from our app. Then Amazon Pinpoint. Pinpoint is an interesting service because it offers two important things, user analytics and user engagement. So the reason why these two are together is if you want to engage the users, you want to know what kind of users they are or what they are having issues with. So Pinpoint offers user analytics where you can understand, like you can see who is buying what stuff, like how much revenue your app is making or where are people facing issues. And then it also helps you send targeted notifications to those set of developers, those set of users. Now, like how do you target these users? So like there are 3 channels offered by Amazon Pinpoint. One is SMS, the other is email, and third is push notifications. So it really covers all the tracks by which you can engage with your users, because like let's think about it, like is there any other way you can know about an app? Probably not. And then we have AppSync up top. So AppSync is one of our newer services where it helps you store and sync data between devices, web applications, and it has it is like a GraphQL API service which helps you front your data sources with GraphQL. Like how many of you know what GraphQL is? Oh, that's great. So GraphQL is a API querying language which allows dynamic querying, like in the way that the client can specify what data it wants to access. So that can be really helpful because You do not want to rely on existing APIs. You do not want to tie your front end to like, oh, this is the API, I have to build around it. No. AppSync offers you to front that API with different sources. So like if you have your data in DynamoDB, great, AppSync supports that. If your data in a SQL database, not a problem. We recently launched support for that as well. So with AppSync, you can connect to any of your data source, even Lambda or Elasticsearch, where you can have any data surface to your mobile app in a query in an API language of your choice and an API definition of your choice, without writing any backend management code or anything. It's a serverless service, so that's one great thing about AppSync. And now, how will we be using this service? Is think about it as I'm uploading so many different photos. Like, how do I know which photos do I have? Like, using S3 for it might not be a great solution. So we'll be using AppSync for real-time updates. Like, well, this photo was just uploaded, so I have my website open and my mobile app open. I'll get an immediate notification that, well, I just uploaded this image from my device. It's available on the website. Or if I have 2 mobile phones, the images become immediately available. And I'll be covering that in our demo today as well. So this is the overall architecture of how this Photos backup application is going to use. And if you see this part, you as a developer will use the CLI toolchain to configure this, and then you're wondering like what this part is. Like, after configuring all this backend, we also have mobile SDKs which help you work with these services directly. So let's cover like what are the high-level features of the iOS SDK which we offer. So the first thing is authorization workflows. Again, like I'll keep reiterating throughout this session that authorization is very critical and has to be well thought out. So in our AWS iOS SDKs, we have fully managed authorization workflows where we take care of the tokens, refresh tokens, getting the correct tokens when required, and the developer doesn't have to worry about it. The developer will interact with simple APIs like sign in, sign out, or like get credentials, and that's it. We will make sure we will do all the right steps to make sure you have the correct credentials with the correct permissions. We have network management. So Apple has a lot of best practices around how to use network correctly. And it's understandable that as a new developer, it might be not possible to adhere to all of that. But what we do is essentially we use most of the best practices which Apple has recommended, like sharing of the URL session object. What it allows you to do is, like if I'm using S3, the same session object will be used while accessing the service n number of times. This makes sure that the connection time, established time is reduced because the servers, the certificates won't be verified again and again. That also helps in saving the battery. We also allow configuring for cellular access versus Wi-Fi access. So there's a simple switch like allow cellular access. You can set it to yes or no. If you set it to no, our whole SDK will behave as if there is no internet when it's on cellular mode without any code of your own. What this gives you as an advantage is that you do not have to worry about whether I'm online or offline. You can just front it with a switch, like as you must have seen with some of the popular streaming apps, like music streaming apps specifically that use in offline mode, and that's it. If the end user hits that switch, you hit the switch in our SDK, and our SDK will make sure to not hit network in any condition. The next thing is caching. Now, why is caching important? Caching is important because of data availability and a good user experience. If you have fetched data once, you can probably reuse that data to make your app experience very smooth and very fast. If you have downloaded a 4 megabyte image, you do not want to download that image again and again. We offer utilities which will keep information about the API calls which were previously made and make it available for reuse later. And this is not only for the data which we are fetching inside the app, even for the data which we are sending outside. For example, I want to upload an app, but I want to upload a photo, but I'm offline. Our SDKs offer solutions which you can queue those uploads without any extra code. The code would be same for whether you are online or offline. And that has been one of our focuses in recent time, where you write the code without thinking about your online or offline, and our SDK will take care of like queuing the call or retrying very frugally or returning an error based on the configuration set and the services which you are using. The last is real-time data. AppSync is one of the services which provides real-time updates about how your data is changing in the app. So we use technologies like MQTT over WebSockets, which are designed around using less network bandwidth and less battery while keeping the data up to date. So we do not want to use mechanisms like polling when required. Like polling is a good mechanism when it's used correctly, but sometimes when the requirement is like immediate access, like real-time updates, you want to use some mechanisms like MQTT or WebSockets, which help you deliver data at a faster pace without using a lot of resources, which includes network and bandwidth both, battery both. So now, focusing on the actual client architecture, well, I'll be doing the demos and the features of the respective SDKs. A quick recap on the requirements. Security, we always have to be mindful of security. We always have to be mindful of the availability of our data, so that will be covered by AWS. Responsive UI, this is where we need to use the SDKs correctly and use the right features and the right configurations offered by the SDK to make sure the app is very responsive. Plan for connectivity and offline data, different connectivities, 2G, 3G, 4G, and no connectivity. And lastly, it's always important to understand the user behavior and the app behavior. These are two very different things. Users can have issues using the app, and the app can have issues in making sure it's available to the user. The business is always interested in user behavior, whereas US developers should be interested in the app behavior, which is covered by the telemetry part of it. So the Cognito SDK. So we have an Auth SDK where we offer things like a drop-in UI, which I'll be demonstrating, that with just like 4 or 5 lines of code, we offer a fully managed UI for signing up a user, signing out, signing in, and that's it. You don't have to write any code. We control the view transitions, we control the flows like forgot password and everything. It's a fully managed UI. With Amazon Pinpoint, we smartly collect the analytics in the way that we by default make you available what kind of device the user is using, what kind of region the user is using. And then when you are collecting analytics data from the users, we also make sure that whatever we collect is cached first and sent in a batch towards the end when the user is done using the app or when user minimizes the app. This makes sure that the app is responsive and you can still get the data. So we have thought about things like this while developing the SDK. AppSync offers real-time connectivity and a GraphQL real-time connectivity and a GraphQL way of interacting with AWS. It also offers storing outward changes in a queue, which will be synced when you are online. So if you are writing a note-taking app, you can just write the same code for online or offline, and the SDK will provide features like conflict resolution, sync on network change, and even real-time updates. So just use the app as you are using normally, or even develop the app like you are developing normally with the same APIs, and the behavior will be controlled by the SDK. The next is Amazon S3 transfer utility. We provide features like background uploads, background downloads, which is important because users are not going to keep the app open like, oh, my photo is uploading, let me see it upload successfully, and then I'll close the app. No, users start the upload and just minimize the app. We offer services like background uploads and background downloads, which keeps the download working even when the app is minimized, so that you don't have to manage all that things. That's done automatically by the SDK. So now I'll move on to the demo part. What will I be demoing? I have written a very, very crude app, and like I spent about 1.5 hours of my time and tried to come up with like, let's see how much I can show that after spending 1.5 hours, I have this app ready for me, which includes backend provisioning. I'll demonstrate like how the app is behaving for a certain use cases in online and offline. Then I'll talk about the visual feedback, like how I am giving visual feedback in the apps to keep the users engaged or informed about what's happening in the app. Then I'll walk through the analytics console, because this is where you'll find some interesting stuff as to how people are using the app or what's happening when the app is out there in the wild. And lastly, I'll also show you what backend resources were configured for this app when I made the app. So I'll jump onto the demo now. Okay, so I'm going to use two devices for this demo. I'm going to use the same user for signing in to both of these devices, and I'll show how the app works after that. So that's not my real password. Okay, so I sign into this app. I see that I have only one image uploaded, which is flowers. I sign into this app, which also has the same flowers. So the UI screen which you saw previously was written with this much code. So let me show you. So that's it. So what I'm doing here is I check if the user is signed in. So if I'm not signed in, I use the mobile client to show the sign-in on this navigation controller, and that's it. And once I successfully log in, there is no error in logging in, I perform the logged in tasks, where I set up the subscription for real-time data, where I set up a query to list my images and things like that, which I'll be covering. And then just a small hello message for the user who just logged in. So as you can see, the message is right here, like, hello, my username, and I'm displaying the data which I had. So with just that much data, I have my full login screen available. And I'll also show you how we also have like create new account, forgot password, and flows like that. All part of the same API which I just showed you. So let's take an image upload here and say this, a waterfall. So I type in waterfall and select OK. So now I updated the status immediately to I'm uploading an image, and I also have a progress bar over here which is showing the progress of the image. And if you see, the moment this was done, there was no update over here in this app, but the moment the waterfall photo was uploaded, it became available in this application. So this is powered by the real-time updates feature of AppSync, where it's keeping track of the images. So there are two things happening here. There is S3 being used for storing your images, and there is AppSync being used to store data about those images. And all that is fronted by sign-in of Cognito, who is making sure you are authorized to upload the photo and even list your photos. And while that's happening, it's also recording data about how the image is uploaded and what was the things behind it. So let me show you the code of what happens when you click the upload image button. So this is the standard image picker controller where you pick the images, and once you are done, it's called here, yeah. So we set the progress bar to 0, like, okay, a new image is about to be uploaded, and we start the upload based on the name given by the user, and then we call the perform file upload. Here we are using S3 transfer utility. So what S3 transfer utility is doing is that you can assign a progress block like this, which will automatically update the progress bar always for you without you having to do anything. You just assign that progress bar progress is like the fraction completed, and that's it. The progress bar will move automatically, and it will be wired to S3 transfer directly. And this is all the code you have to write to wire that up. And how the actual upload is, like, so I'm also recording this, like, if you see the start time and the end time here, the end time is recorded in the completion handler of this upload task, and start time is recorded just before I call the upload. This is for my telemetry purposes, where I'm going to record how much time it is taking for me to upload that image. So if you see here, It's a very simple API, like transfer utility, the default location, upload this file, the local path where you want to store it on S3, and it's a JPEG image. That's it. And once this image is successfully uploaded, I log a successful upload image, and I create an image entry in AppSync. The moment I create an image entry in AppSync, it will notify all the clients who are waiting that like there is a new image entry available, update your views. And the interesting part is how the update view code is written. So we have this concept of watcher. So what this watcher is going to do is, if you see this watcher, it says like, well, get user query, and the get images are always part of a user. So that this does two things. A get user on the username will make sure that I am the same user who is accessing my details, which includes my photos. If I can't access my details, I sure cannot access my photos. So if you see images are part of the get user property, and then there is items. So if there is no error in retrieving the user, I can access my images. So what happens here, a watcher is going to watch for data changes locally as well as in the remote world. So it sets up a watcher on the cache, which is local, and whoever is modifying the cache, like if you uploaded a photo locally, you update the cache locally, and the watcher will fire like, okay, I got a new image. If it's uploaded on a different device, the watcher will again fire up and say like, okay, there is another device which got an image. So there is this literally the same code which is powering the whole list view and the images view. And that's the best part of it. So with techniques like this, you just have to write code once, and it works across different networks. And if you see this cache policy, return cache data and fetch, that's where it gets more interesting. You can specify different cache policies to design the data access pattern for your app. What this policy is doing is, as it says, first look into the cache, return what images I have, and then check into the network if I have any more images. What this is going to do is, the moment your app loads up, you immediately get some images which were fetched previously, which is great. Like, okay, I remember seeing this list of images, and then it will, in the background, fetch newer images and also append it to the list. This kind of makes sure the user always has some data to see, and the same code is used to keep the list intact. So now if I sign out of the app, or let me show this first. So if I click flowers, great, this was downloaded already, so it was very quick to load. Now if I do waterfall, this was a newly uploaded image, so it's taking its time to load, and now it's visible. And the next time I want to open the waterfall image, it will be instant. This is because I have a cached copy of the image in my documents, and that's it. Like every time you call it, I'll check the documents. If it's not there, I'll fetch it and I'll load it. So here's the code for it, and it's really easy code. So that's it. This is a small tiny function where I check in the document directory if the file is existing. Else I use transfer utility to get the image, stop the animation, and load the image. In case of offline, what I'm doing is, like, if there is some error written, I'll just load an image which is a load error, and you can see it on the screen immediately that it cannot be fetched. Now, I'll walk through the analytics part of the thing now, and then I'll demo the offline part of the app. I do not want to disconnect the Wi-Fi before I finish the online demos. So now moving to the console, let me refresh this so it captures our most recent upload. So if you see this console, let me zoom in. So I'm focusing on the data from last 5 days. So let me come here and then select an event type. So image uploaded. So every time an image is uploaded, I have this event which is I'm recording. And you also remember the start time and end time, right? So there are 69 times images were uploaded in the last 5 days by different users. So let us see how much time it took for them to upload. So in total, they have spent about 744 seconds uploading all that data. And let's see what was the fastest one. So the fastest one was like 26.5, and the slowest one was 74. You can get data, and then you can also see data like, say, image type. So what kind of data are people uploading? So currently we only have JPEG and PNG. So if you see JPEG, 41 of those were JPEG, and then you can see what was the upload time for JPEG. So then you can even add additional filters and see things like, okay, 14.5 was the minimum for JPEG. This is how you understand like what kind of features are used by the users in your app, like what is the experience they are having. If you see a number like 500 seconds for uploading a photo, something somewhere is not right, or the network condition is too slow. In that case, you must have additional attributes tagged like network type. So something which I have not done but would be a good thing to add is log what kind of network was used to upload this image. So you can then see like, oh, for this thing which took 400 seconds, it was a slow 2G connection, and that's why it took long. So this is, the app is working as it should be, which is great. Then there are other things which you can also record. So some things like revenue. So currently, if you see in the code, on a successful upload, I'm logging two things, like the attribute type, what kind of image it was, the time taken, and I'm also logging that for every image upload, it's 10 cents. So I know nobody's going to have a price like that, but this is just for a demo, that it's 10 cents for every upload, and it's in USD, and it's tagged with the image upload event. So now if I go to the console, for revenue, it will show me that in the last 5 days, there are 4 paying users, and the revenue is about $0.84 on average for every user, and per user it's $1. Then you can also see things like funnels. Now funnels are really great way to understand like what's the pattern in which every user uses the app. So I have one simple pattern over here which is recording. So for every time the app is started, so the app was started 111 times in the last 5 days by different users. And out of those times, 69 times the users ended up uploading a photo, which says that the primary use case is working great. Like this is a really good number. Every time an app is launched, if somebody is actively uploading an image, they are probably liking the app and are having no issues. But if this number was like say 1 or 2, it says things like in a simple app like this, if it was launched 100 times, is it really that only one user was successfully able to upload a photo? So you can record events and analytics like this to better understand your user. And now I'll move to the offline demo part of it. So I'll just go ahead and turn my Wi-Fi off. And say I go back to my simulators. So what happens is essentially now in this app, I had fetched the data like already for flowers and waterfall. So if I'm using this app now, great, like there is no issue whatsoever. It's still working, and I as a user am not concerned about something. But now if I come to this app where I had not opened any images, you'll see a spinner, and what the SDK is trying to do is like back off and retry for a bit and make sure that the network is not flakily down or connection. And once it gives up, it will display an error image of some sort. Like let me see if my image is loaded correctly. Yeah, it should show this image. Let me check. I'm sorry for that. But but the SDK will identify that the app is offline and won't load the image. So that's the part for offline demo. And if I say kill the app and relaunch it, so I kill the app and I launch this app again, it's instantaneously going to show what images I had because it knows it had cached it previously, and the behavior will still be same if I'm offline. So this is all handled in the exact same code as it would be for an online use case. So now moving on to the presentation again. Some useful tips for programming. Fetch data smartly. This is which kind of always hinges the user experience. You have to make sure that you load the data in advance when required. You don't load it when it's not required, like don't excessively load it and things like that. Respect users' network bandwidth and memory. Apart from security, this is one thing which personally matters a lot to, say, me as well, because I do not like when apps excessively consume memories. Like I have seen some apps that the moment I put my phone on offline mode, they keep retrying to connect in background and just drain away my battery. I'm pretty sure a lot of people don't like that, so we should not be writing apps which do that. The next is designing for visual feedback. Like if you saw my app, I had a visual feedback for most of the activities, like I had a text, or I had a progress bar, or I had an activity spinner. And you can see like if the error is not displayed correctly, which happened in my demo, the user experience will not be good. Like, why is this still loading? Like, I don't like this. Either tell me that something's wrong, or tell me, because even if you're connected to Wi-Fi, you might have no network access. So it's important that you do not rely on just like a Wi-Fi being present or no, but you rely on the actual underlying calls and reflect the UI correctly. So the takeaways. Focus on your app development. As mobile developers, we want to focus on writing our apps, and we should not worry about backend. Like backend management does not require you to have dedicated teams which are working around the clock. Now with all the serverless technologies and other tool chains, it is possible to start an app alone and have a scalable app. So in all this demo which I did not write a single backend line of code. Like it was all managed resources through different services. And I didn't have to worry about any servers or infrastructure, and like that was great to me. I know iOS programming and I was able to write my app. I would recommend to do the same. Analytics and telemetry is critical. You want to know if the app is working correctly. You want to know if the users are able to use it correctly and if they are having any issues or not. And lastly, offline is required and is easy, and it should not be too much of an effort supporting all the offline cases. And at AWS SDKs, we take a lot of effort to make sure that offline is readily available for everyone to use. And that's my session for today. And like, if you have questions, we have the mics ready. Please ask me anything which you would want to know about this. Thank you. And also, you can complete the survey in your mobile app, so I would recommend to do that as well. And I'll be hanging around here for a few minutes. If someone wants to ask me questions, they can even drop by here. Like, feel free to reach out to me for that.